Cool. Thank you. Oh, wow, that was loud. So yeah, look, it's falling off the edge, practical uses for edge computing. Today we're going to talk about the history of edge computing. We're going to try and cover some key terminology, because you're going to need to kind of understand that. And then you can forget about it after the talk. It's fine, don't worry. And then we're also going to cover some practical uses where you can start taking advantage of it today. And we'll also cover some of the pitfalls, right? Because there's a few of those to watch out for. Look, I hope you find this talk interesting. I find it interesting, so hopefully you will too. A little bit about me, like I said, my name's Alexander. I'm a senior software engineer at Atlassian, where I work for the Cloud FinOps team, where we help sort of make our cloud infrastructure more efficient through architecture and code changes to reduce our cloud bill. If you're interested about that, you can come and have a chat with me afterwards. But hey, let's jump into it. So what is edge computing, right? So this is the most important thing to understand. It doesn't actually refer to a particular technology or stack. It's a distributed programming pattern with a focus on where things are placed in the network. So it has nothing to do with a set technology. But hey, maybe that was too much for the first talk of the day after the keynote. So let's simplify it. It's running code as close as possible to the end user. But then maybe I've simplified it too much, so we'll just roll back a little bit and say it's running code as close as possible to the end user that's globally distributed, right? So hopefully you're all with me so far. So you've probably seen things like this over the last few years. I know AI is all the hotness now, but there was once upon a time where it's like edge computing, it's the future, edge functions, your full stack web framework is edge ready. And you've probably seen things like this. Like here we're using Vercel and SvelteKit to render a web page using edge computing, and we're using something called edge middleware to inject the city and IP address into the page. Now, we'll cover how this works and why it's really good in a few slides, but before we can understand what this is, we actually need a brief history lesson. Yay, history. So we need to rewind the clocks back to the very first internet that connected 4 universities in Northern America, and the acronym for this internet was the ARPANET. I hope I'm pronouncing that right, might be wrong. But anyway, an RFC was launched that detailed the information on how a user on the ARPANET could send and receive data with a server host. And that first server was the IBM 369 and I've included like the best quality photo I could find of it, but they're all pretty old and in black and white, but you get the idea, right? So it's a really beast of a machine. And of course, the way servers work have changed a lot, but the basic protocols for how a user sends and receives information are the same. Now, as the internet grew in the late 90s, this initial setup started to run into issues. So CDNs were created. So CDN stands for Content Delivery Network, and hopefully most of you are familiar with them, but it allows us to cache static content close to our end users. So dynamic content would come from the origin server, but like images, HTML, CSS, files, those would be stored in CDN servers all around the world and delivered from there. Now, some of these networks started to evolve in the early 2000s to bring us our very first edge computing services. Now, you're probably like, wait, I thought edge computing was a new thing, but remember in tech, everything old is new again. So some of these first edge computing services were really cool. The first one was actually Microsoft Windows 2000. I might be wrong if it was the first, but it was one of the first. But basically allowed users to access multiple files stored on multiple servers, but it seemed like they were stored on one. And this allowed them to sort of reduce the load on that individual server. Another great example of the first edge computing sort of services is AWS CloudFront. That came out in the mid-2000s, and it came with a CDN that allowed you to store dynamic and static content. So instead of just being static, it was dynamic as well, close to the end users. Anyway, so that's the history lesson over. But before we jump into the meaty bit, we're just going to take a little detour for a second. And you might be like, this has nothing to do with the talk, but I need to hit home that edge computing is an architecture, not a particular technology. Because once we get into the meat of it, we'll probably forget about that. But we need to think about the iPhone, right? So the iPhone does a lot of things on the phone, like biometrics, security. A lot of this stuff happens on the phone instead of on the servers. And there's a lot of reasons for this. Security is one of them. But this is a form of edge computing. Apple updates, manages this code. For them, the iPhone is the start of their network, and they're choosing to run that code as close as possible to the end user. And we can take this further with IoT devices or Internet of Things, right? We all have smart speakers, cameras, sensors, you name it, right? There's so many now. But these devices have got way clever over the last few years, and they're now running ML models on them. And once again, the companies responsible for these devices, they're the ones shipping the updates, they're the ones managing the code, they're choosing to run that code on the device rather than their server. So that is a form of edge computing. Now, you could argue that I'm wrong, because as with everything in tech, pretty much everything is up for debate. But this is a form of edge computing. But let's focus on what you've probably all heard of, and that's edge functions, right? What is an edge function? Well, over the last few years, service providers like Netlify and Versal have been rolling out edge function-ready frameworks or edge functions for their users. Netlify Edge is a really great example. Netlify Edge is an advanced global platform for powering web experiences that are fast, reliable, and secure. Make your websites feel nearly instant for every visitor. Or my favorite one, Cloudflare Workers. You write code, we handle the rest. I really wish that's how everything worked. Deploy serverless code instantly across the globe to give it exceptional performance, reliability, and scale. So let's put the marketing spiel aside for a second. What does this mean? Well, to understand what an edge function is, we need to understand what a serverless function is, right? So hopefully most of you know what a serverless function is, but in case you don't, quick explanation, right? A traditional server, you pay your cloud provider, and you pay for every minute that it runs. A serverless function, on the other hand, you write the code, and you only pay for the time that it's running. So a really good example, for an API endpoint, I might write one serverless function. That endpoint gets called. I literally only pay for the time that it's processing the request, and then it goes back to sleep. Now, edge functions are like serverless functions, and CDNs came together to have a baby, right? So they're serverless functions distributed across the globe, running as close as possible to the end user. Now, they're actually better in some ways than serverless functions, because they don't suffer from things like cold starts, typically. Doesn't mean you can't also code them in, and we'll cover that in a minute. But what's a cold start? So with a traditional serverless function, the first time it's called, it's got to wake up and provision everything that goes with it to make it work. And that delays the initial response, and that's called a cold start. Every request that comes afterwards is a lot faster because it doesn't have to do that. But if enough time goes by without that function being called, it goes back to sleep, and the next time it calls, it's got to wake up or warm up again, whichever way you want to do it. Now, there are ways around that as well, but traditionally, like I said, edge functions don't suffer from that cold start, and we'll cover why in a minute. So frameworks like SvelteKit, Next.js, Deno and Fresh, they've started moving from serverless functions to edge functions to render pages in their application. So another key term you've probably heard is edge runtime, and this one's a little tricky, okay, because it doesn't actually have a set definition, and people use it interchangeably. When I first gave this talk, this slide wasn't even here, and then after like a big firestorm on Twitter or X or whatever the hell that site's called these days, I had to add this in. So what does edge runtime mean? Well, a general rule of thumb is it's more about the environment that the service provider you choose runs your edge function in. And what do I mean by this? I'm not too sure if you can see this because we're outside, and this is like a dark theme slide, but let's roll with it. So AWS Lambda, for example, they use Node.js for both their regional and edge functions. And when I say regional here, I mean like more traditional serverless setups, like when you launch a serverless function, it goes to one data center. Cloudflare Workers, on the other hand, they use V8 isolates for both regional and edge. And tools like Deno Deploy use their new JavaScript runtime Deno for edge deployments only. They don't have a regional setup currently. And Cloudflare Workers are a really great example of why edge functions don't suffer from cold starts. So bear with me here. I'm going to hit you with some little technical stuff. So traditional serverless providers use a containerized or virtual machine to run an instance of a language runtime. Now, Cloudflare Workers, on the other hand, they use something that pays the cost of JavaScript once at the start of a container, right? And then they're essentially able to run limitless scripts by running an isolate for each function call. Now, this isolate can start up to 100 times faster than a node process running on a container or virtual machine, and it also consumes a magnitude less memory. And it's because of that that they don't suffer from cold starts. But like I said, you can still code them in. And the last place that you've probably heard of edge runtime, and this just feels a little moronic, but there is actually a project by Versal called Edge Runtime. And it's about providing a comprehensive universal API layer for JavaScript. And there, the term edge more refers towards this instant serverless compute than locations, because they were like, hey, let's just swap it around what it means, you know? And it's part of this Winter CG group, which is an organization of companies coming together to create this unified API layer for JavaScript. So wherever you're using JavaScript, you have access to the same libraries, whether it's a browser, a server, an edge runtime, embedded applications. Kind of think how like we've just got Fetch in Node, or I mean, it's been there for a while, but you know what I mean? Like we're trying to make sure we have the same APIs. So finally, before we jump into how you can start using it today, why do we need edge computing? Well, the simple answer is speed and data, right? So the world's data is set to grow to 175 zettabytes by 2025. Just to give you an idea, 1 zettabyte is 1 billion terabytes. I hope I'm pronouncing zettabyte right, might be zettabyte, who knows, but I heard someone call Deno the other day, so all bets are off on how we pronounce words. But look, we've seen significant progress in network technology over the last 10, 20, 30 years, right? But if the world's data continues to grow at this rate, there is a chance that cloud providers might not be able to guarantee acceptable uploads and download speeds. Now, of course, I don't want to be one of those people that's like, it's data-geddon, we're all going to die, because that's climate change, not data. But, you know, the thing is, we need to think about this thing, and edge computing is actually one of the answers to this problem, right? By distributing your applications and data across the network, you can lower the bandwidth your application uses and help ensure those speedy upload and download times. So let's look at a little test that you can't see because it's black and it's code and this room's outside, but for those of you who can see, this is a AWS Lambda node function that returns a half-baked JSON API response. And then this is the same function written in JavaScript but slightly different and deployed on Deno deploy. The only reason it's slightly different is obviously I had to use Deno's server, not the one that comes with Lambda. And like I said, it's just a half-baked JSON API response. Don't kill me for not doing it properly. But hey-ho. So I pinged both of these servers from Perth. So the Deno one is deployed all across the world. The AWS one is deployed in Sydney. Now, fun fact, when you ping this from Perth, AWS is actually faster sometimes because our nearest edge location in Perth is just as far away as AWS is because no one cares about Perth. Anyway, but if I put my VPN on and I ping it from Germany, of course it's got to go to Germany and back. I get a much faster response time for the edge function because it doesn't have to go all the way to Sydney and back from Germany. It hits the nearest edge location in Germany and comes straight back. And we can see the same again if I ping it from the US. So you can see, hopefully start to see the advantages, right? By deploying something on an edge function, no matter where I am in the world, I'm going to get a pretty fast response unless I'm in Perth, right? But like pretty fast, right? So let's dig into some practical uses and some pitfalls. So you can go away, convince your boss or manager that you need to now just put everything on the edge. No, not one of those people. Don't put everything on the edge, and we'll get into why, right? But the best example of where these things shine are full-stack web frameworks. So think Next.js, SvelteKit, you know, running on Versal or Netlify. Because if you're using anything else at this point, you're doing web development wrong. Let's just be really honest with ourselves. Now, I jest. You can do this stuff with Nuxt, Remix, I'm trying to remember all the web frameworks, Astro, Deno, Fresh, Solid. I feel like there's too many to remember them all, but you get the idea. This is achievable with most full-stack web frameworks, right? So SvelteKit, for example, uses functions to render its web pages. So if we stop using serverless functions and move to edge functions for rendering those pages, we can get some pretty damn fast response times. And then if we inject things like edge middleware, so edge middleware is something that processes the code or the request before the rest of the site does, we can do some pretty cool stuff. So think back to this page I showed you at the beginning. Here we've got my city and IP address showing in the page, right? And the way this happens is the edge function picks up my location from the request and dynamically changes the way the page renders. Some great examples of where you could use this. Say we've got a web app that's only available in Australia. If you're in Australia, you get the sign-up page. If you're outside Australia, you get the register your interest page. Say we've got a few customers that we know we're going to be releasing to soon in other countries, we can add an edge config that maybe registers a half-baked sign-up page that notifies them when they can log in. We've got these different options. And you might be thinking, why are we doing that? Well, you get faster dynamic page loads, right? So you can create dynamic content that loads incredibly fast because it's loading right near the end user instead of coming back to your origin server. And we can take this further. We've all done A/B testing before, right? Like it normally involves multiple trips to the server and lots of client-side code, multiple versions of a feature or page. Well, yeah, forget about all that because it's much easier when you do it on the edge, right? We can cache a version of each feature and page on the edge network and decide which version to render when the request comes through. So we get this dynamic switching of features or versions of a page because it's happening really close to the end user. So we're coming back to speed a lot, and you might be like, hey, Alex, speed isn't that important. Well, it is, right? Not everyone has the best laptop or phone, like probably everyone in this room does because you work in tech. Always remember that when you're building stuff on an M1 and everyone else has got a Windows 2000 laptop. And we all know that Google study, right? That's like 53% of visitors will abandon a web page if it takes longer than 3 seconds to load. Well, we can start doing dynamic stuff and still get under that time. Right? And maintenance page, we've all ran a promotion or pushed an update and something's gone wrong. Well, with an edge config, we can flick on a maintenance page just like that. And I'm going to borrow a Versal marketing term here, so please don't shoot me, but give your users dynamic at the speed of static, which now I say it out loud, it's like, what does that even mean? Just because something's static doesn't mean that it's fast, but that's the idea, right? And look, it's going to seem like I'm pumping up Versal a lot, and I'm really sorry. You can do this with other service providers as well. It's just I spend a lot of time in Versal, so that's what I know well. So I'm going to talk about them a fair bit. And also AWS, but like I say, you can do this with Azure, with lots of other service providers. Okay, so we've got dynamic content, right? We've got a full stack web framework, we're rolling, we've got all this cool dynamic content on the edge. What if we need a database? What if we need persistent data? Right? Well, how do we do that on the edge? And if any of you have ever worked with a database, I'm sure you're like, distributed data, that's a bad idea. And you're right, it is a bad idea, but hey, let's roll with it, right? So let's look at Versal edge functions for a second, right? They've got a code size limit of 1 to 4 megabytes, maximum memory usage of 128 megabytes, an initial response must be within 30 seconds, right? So most edge environments run a lighter version of JavaScript, and so you don't have access to all the same node libraries or NPM packages you might be used to. And that's right, most edge environments are JavaScript. So if you hate JavaScript, the rest of the talk isn't for you. Anyway, so you have to think carefully about how you're going to connect to database. Now, since I've started giving this talk, Deno has released updates. You can now use all of the core node libraries on Deno. That literally happened an hour after I gave this talk in Norway, or I gave the talk again in Melbourne a few months later, and literally the same day while I was giving the talk, Deno was like, hey, you can now install all NPM libraries on here. So check with the service provider you're using because what's available is always different because being confusing is how we roll. So anyway, back to the database setup, right? A traditional server spins up, it creates a connection pool and uses that to talk to the database. Obviously, it's a lot more complicated than that, but we're simplifying for the sake of the talk. A serverless function, it spins up, it caches a connection to the database and uses that cached connection to make further requests. Now, this is another thing that adds to cold starts because say your function scales, right? It's getting lots of requests, so another one spins up. And that now has to create a new connection to the database, which also slows its initial response down. But we can't necessarily connect to a database via a driver on an edge function. So we use HTTP, right? So we can start using MongoDB right now on the edge, right? We can use MongoDB Atlas to manage the database, because who wants to do that anymore? And we can create, read, update, and delete data all over HTTP. Nice and easy. But let's take things further, right? Let's think about serverless MySQL, right? So PlanetScale has gone to incredible lengths to create a fetch-based library that allows you to connect to their database from serverless functions and edge functions. And you may think it's going to be slow, right? Because I'm like, well, it's still got to go back to the database with each request. And we'll get to that. But the thing is, they've gone through some incredible lengths to work on global routing. So basically, if you make a request to PlanetScale, it connects to their nearest edge location and uses long internal held connection pools to reach its destination. And when you combine that with rendering on the edge close to the user, caching on the edge, and PlanetScale's global routing, you can get some damn fast database reads and writes on the edge, which is pretty cool. However, this is where the first but comes in, and the thing you really need to think about is that a relationship between a server and a database is a lot more complicated than a client and a server, right? So I'll give you a very simple example. Say we've got a page that lists all the users in your account, right? If things are done correctly, that should be one request from the client to the server, right? But from the server to the database, that might be 2 or 3 requests. And the thing is, if my server is here in Perth, but my database is in Germany, and it's got 2 or 3 requests, that's got to go to Germany and back 2 or 3 times. Where if I just put my compute next to my database in Germany, it'd have been 1 request there and back, making it much, much faster, right? So this is one of the pitfalls. You need to start thinking about where your data is located versus your compute. And when I say compute, I mean those serverless or edge functions, the general server stuff. Now, tools like Next.js already take this into consideration. They have this beautiful config file where you can choose what type of compute you use per route. So you could be like, maybe serverless for this stuff, it's pretty data intensive. Edge for this stuff, it's not. But hey, there's tools that are starting to make that not a problem. Deno KV, or Key Value Database, right? It's built on top of Foundation DB, so it's used by iCloud and Snowflake, so you know it's good. Supports ACID transactions. Now this stuff, this is pretty good. So I got on the beta when it first came out. But basically, it allows you to read and write JavaScript values from anywhere on the edge. And the thing is, it lets you choose the consistency level when doing reads. Because think about it, right? If I've got a user here in Australia, a user in America, and we're updating the same table or collection, depending on what type of database you're used to, there's a chance I'm going to get stale data when doing a read, right? Because if it's got to go further, well, you choose a consistency level, right? You can choose high consistency, get a slower read, but always the freshest data, or a lower consistency and get a really lightning fast read, but there's a chance the data might be out of date. Now, what's this really good for? Real-time user collaboration data, authentication, user management, stuff like that. You can do some pretty cool stuff. And, where would I be without mentioning my sponsor, Versal? I wish. They've got their own key value database now available, their own serverless SQL. They've also got blob storage via R2. And I'm really scratching my head as like, why would you not just use Cloudflare's R2 directly? Like, surely that would be better, but maybe there'll be some DX improvements on the top. Who knows? So what if we need more, right? So we've got a full stack web app. We've got serverless and edge functions. We've got a database. We're rocking and rolling the serverless edge lifestyle. What if things get more complicated, right? And one thing I will mention of this whole serverless and edge function setup is that sometimes something that you could do with a traditional server in like 2 seconds flat, you've now got to reach for another monthly subscription to pull off. So just bear that in mind. I mean, it's not always a big deal, but I feel like it's worthwhile mentioning, especially to like indie or smaller developers, that cost is really important, right? But the thing is, tools have evolved. Cloudflare Workers actually has a cron job function you can use to run background tasks. If things get more complicated, we can use tools like ingest to trigger background jobs from anywhere on the internet. But let's take it a step further, right? Let's say things get complicated. Let's say we now have a mobile client to support. Let's say we have more clients to deliver our API to, not just ours, right? We've signed a few commercial contracts, and They don't want to use your web app. They want to build their own, and they want access to the API. How do we build an API? On the edge. Well, the reality is, right now, we could go use Deno deploy, right? We could go build an API in Deno that looks like something Node Express, Ruby on Rails, Django that you're all used to, deploy it with them across the edge network, easy peasy, connect to MongoDB, Planet Scale, Deno key value, Firebase, Supabase, you name it. And I have to give props here to Deno on just how easy it is to deploy stuff in TypeScript. It really is fantastic. And I'm going to be honest, if I had to choose software based on cuteness of logo alone, like Deno, like it's a dinosaur in a spaceship. Actually, you know what? Let's take a little detour here. They've got this art page on their website. Like there's some like Deno reading the news, Deno Simpsons, Space Deno. Like what more could you ask for, right? Like seriously, I would literally use nothing else than this if that's how we evaluated software, right? So you can do some great stuff. There's a wonderful framework called Hono. I think I'm pronouncing that right. It means flame in Japanese. And it's a API framework that's built for the edge, right? You construct larger applications by combining middleware that run on CDNs. And it's also got this fantastic tool which allows you to configure it for Cloudflare workers or AWS or Deno deploy, right? So you don't have to take care of that layer underneath. And it's well worth checking out. Where would I be without mentioning Bun, right? Because in the JavaScript ecosystem, we were like, things are too complicated. Let's have 3 runtimes, right? Be interesting to see how that plays out. But like one of the reasons this was made was because performance was a key focus, right? Compute is moving towards the edge, and it's predominantly JavaScript because, you know, it's the best language ever. But, you know, this is why this came around. So it'd be interesting to see how this makes edge computing better, hopefully. But hey, look, say you're still like, I don't want to think about where my compute is versus my data. That's too much work. I get it. But Cloudflare workers can do that for you. They've got a thing called smart placements where they'll analyze how many requests are being made, where your data is, all that sort of stuff. And they will move your compute to edge or regional based on those requests. I mean, Versal even has a feature where you can sort of choose regional edge, which is like a compromise between serverless and edge functions, so you can sort of get a bit of both worlds, right? So that headache can be taken away. But hey, look, let's say that you've got legal requirements, your data is in a set place, you've got other things you have to interact with, and like you can't do that, right? So we could still take advantage of the serverless setup. We could spin up an API with Docker images on Amazon ECS, or like I said, build an API with Lambda functions, and we can connect that to an API gateway in AWS and edge optimize certain routes. So we still get the advantage of some of these edge stuff without, you know, fully giving in to everything being on the edge. So what are my key takeaways, right? So if you're building a web app, let's make it edge ready. You're going to be foolish if you don't start taking advantage of this, especially if you're using a full stack web framework. There's just so much cool stuff you can do, and you can deliver a better experience to your users, and that's actually our job, believe it or not. Think carefully about where your data is versus your compute. You know, that's also really important. Edge computing is not a one-size-fits-all. Please don't just start shoving everything on there. And if you're building an API, maybe don't start on the edge. Maybe don't go, everything on the edge, and then be like, oh, that's a problem later on, right? So it's a great tool. But one of the other great things, and this sort of ties into my job at Atlassian, right, is that we can, by using edge computing, we can make our systems more performant. And you know I'm going to mention this if you know anything about me, but like climate change is a real threat, right? We've all witnessed the summer that's happened in Canada, in Europe, like, and it's our turn. It's already pretty bad, and it's not even the start of spring. So you can all do your part by introducing performance-focused development to lower the emissions of your product, right? Because climate change is a problem, and we need to deal with it. We can't just ignore it, or our future is gone. And it's really hard for me to not mention the fact that one of our key sponsors this year is a fossil fuel company that has no interest in decarbonizing or securing our future. So I think we need to think very carefully about giving companies like this a social license to just wash their hands of the future they're not only ripping out of my kids' hands, but our hands too. Anyway, on that note, I would like to thank you, the other sponsors, for putting on a great event, and also all the organizers, because it's very hard. Like I said, my name's Alexander. You can find my website here if you want to see what I do. And look, if you have questions, I'm happy to answer them. Even if they're technical, I'll give it my best shot. Thank you very much. Just go for it. Let's roll.
Hands up if you have any questions, and I'll come round with a mic.
Hi, Alex. To take your example about, depending upon the user's location, whether you show them a sign-up page or a register your interest page, you were talking about making that decision on the edge. Is that with information, like when the code's running on the edge node, does the edge node tell you where it is? Or are you still doing something like the geolocation based upon the user's IP ultimately?
Both are possible.
Okay.
Yeah.
Because the edge node is a proxy for where the customer is, because you would think that they're going to get given an edge node close to them, but it's not perfect. So it's an approximation, but it's not precise.
Yeah.
Right?
So I would choose the request first, and then if they've got stuff that masks that, because that happens, or it's malformed, then you fall back to the location of the edge node, right?
Okay. So prefer IP geolocation based upon the... Yeah, okay.
Yeah, and like I said, it runs really fast, so it's pretty good.
Okay, thanks.
No problems. Oh, wow, that was easy. No, put your hand down.
Hello. What's your opinion of GraphQL for edge computing?
Look, so I actually specialize in APIs. That's my jam. For those of you who don't know, I run the APIs You Won't Hate newsletter. Go check it out. Look, API development, whether it's REST or it's Graph, like they're all good. They both have their pros and cons. I personally prefer REST for most things, but like GraphQL it's fucking great too. So yeah, look, totally worth it, totally good, not a problem.
Okay, cool. Thank you.
Any other questions? And if I can just get those people in the back to quiet down, please. Thank you.
So are there any non-JavaScript technologies in the edge?
So Cloudflare workers do actually support multiple languages, not just JavaScript. They do C++ off the top of my head, a few others. So there are a few other languages, but I would say it's like 90% JavaScript based. And the reason for that is quite tied to web development. And look, I mean, I'm not a die-hard fast on any language. Like JavaScript is my main language, but I work at Atlassian, right? So my second language is Java and Kotlin. So look, I would definitely say that Cloudflare supports a few, but the reason that there's a lean towards JavaScript is because one, of the environments that they run, and two, because of like how tied it is to web development. But yeah, like check Cloudflare workers out. They support quite a few. Is that it? No? Oh, no, more, no.
Sorry.
It's all right.
You say build edge first, but what if your application is only like state-based, like WA, for example, where you don't have a user base outside of that, and there's no plan.
There's no point. Yeah, just don't waste your time, right? Like, so Australia is very unique as well to the rest of the world because we have lots of internet black spots in comparison to like Europe or America. Our states are so big. WA is half of Australia, best state in Australia. But, you know, it's still half of Australia, right? So, yeah, it would be no point if it was just WA. Oh, no, we got one at the back.
Lucky last question.
There we go. Be kind.
Hey, I'm new to this stuff, but I'm looking at that and I'm thinking, as you start to homogenize APIs and so forth, you could monitor these things and you could tell ultimately where it would best run. There's a chance you could do that. Is there movements towards that?
Well, like I said, so Cloudflare Workers has this tool called Smart Placements. It's still in
Okay, I
beta.
missed that.
Yeah. And what it does is it detects those requests between the server and the database, and it optimizes them for you. So you do have to think about it with most edge providers, but they're starting to roll out this tool of, you don't think about it, we'll do it for you, which is great for some stuff and bad for others, right? We all good?
Thank you, everybody, for coming to Alexander's talk. Can we give him a round of applause?
Thank you.